The gentle physics of zero gravity. Life aboard the ISS narration, a sleep and relaxation experience. Welcome, dear listener, to a peaceful journey through the cosmos. Tonight we travel together to a place where the familiar rules of gravity gently release their hold, where the weight of the world quite literally lifts from your shoulders, and where the serene silence of space cradles humanity's most remarkable outpost. This is the International Space Station, a home among the stars, a laboratory suspended in the endless dark, a place where the gentle physics of zero gravity shapes every moment of existence. As you settle into comfort, allow your breathing to slow, let your muscles soften, and permit your mind to drift upward, past the clouds, past the atmosphere, into the velvet darkness where this extraordinary station makes its home. There is no need to hold on to the concerns of the day. Here, in this space between wakefulness and dreams, we shall explore the wonders of life in microgravity, one gentle discovery at a time. The story we share tonight unfolds across many hours in unhurried passages that mirror the slow, graceful movements of astronauts as they float through their orbital home. There is no rush here. Time moves differently among the stars, and so shall our exploration. Let each word carry you deeper into relaxation, each fact become a soft stepping stone toward peaceful rest. Close your eyes if you wish. The images will form themselves in the quiet theater of your imagination, painted in the soft colors of Earth as seen from above, illuminated by 16 sunrises that grace this station every single day. This is your invitation to float, to wonder, and to rest. Let us begin. Segment 1. The nature of weightlessness. In zero gravity, everything floats. This simple truth holds within it an entire universe of wonder, a fundamental reshaping of how matter behaves when freed from the constant pull that governs our earthbound lives. Astronauts drift gently through their modules, their bodies suspended in air with no effort required. Tools hover exactly where they are released, waiting patiently until a hand retrieves them. And water, that most essential substance of life, transforms into something magical, forming crystalline droplets that dance and merge and separate again, each one a perfect sphere reflecting the light of distant stars. Imagine for a moment what it would feel like to release an object from your hand and watch it simply remain there, suspended before you as though held by invisible strings. There is no falling, no clattering to the floor, no scrambling to catch what has slipped from your grasp. In the gentle physics of the space station, objects simply exist where they are placed, drifting only when touched, responding to the slightest breath of air with lazy, unhurried movements. This is the first gift of microgravity, a world where the very concept of dropping something becomes meaningless. Yet here is a curious truth that surprises many who first learn of it. The International Space Station is not truly in a place of zero gravity. The gravitational pull that keeps the moon in its eternal dance around Earth, that holds our planet in its orbit around the Sun, that binds galaxies together across incomprehensible distances, this force does not simply disappear as one rises into the heavens. The station orbits at an altitude where Earth's gravitational influence remains powerful and present. The secret of weightlessness lies not in the absence of gravity, but in something far more elegant, The station exists in a state of continuous freefall. Picture this gently in your mind. The International Space Station is constantly falling toward Earth, just as a dropped stone falls toward the ground. But the station is also moving forward, traveling around the curve of our planet at tremendous speed. These two motions combine in perfect balance. The station falls and falls, yet Earth's surface curves away beneath it at precisely the same rate. The station never gets any closer to the ground. It falls forever, in an endless, graceful descent that carries it in a great circle around our world. This is why everything inside the station floats. The astronauts, their equipment, their food, their water, all of it is falling together at exactly the same rate in the same direction. When everything around you falls in perfect synchrony with your own body, there is nothing to push against, nothing to create the sensation of weight. You float because you and everything around you are engaged in the same elegant, eternal fall. The gravitational pull on the station is about 89% of what we experience here on Earth's surface. That is not so very different from what you feel right now, wherever you are resting. The force is still there, still reaching out from our planet's core, still exerting its invisible influence. But the sensation, the experience, is transformed entirely. Weight becomes weightlessness. Heaviness becomes lightness. The burden of gravity dissolves into the freedom of floating. This sensation of floating comes from the perfect balance between gravity and orbital motion. It is a dance as old as the cosmos itself, the same dance that keeps moons circling planets and planets circling stars. The station has simply joined this ancient choreography, and everyone aboard has become a dancer too, moving through their days with a grace impossible to achieve on Earth, liberated from the constant effort of supporting their own mass against the pull of the ground. When astronauts first arrive at the station, they must learn to move in entirely new ways. Walking becomes meaningless when there is no floor to walk upon, or rather, when the floor and ceiling and walls are all equally valid surfaces on which to travel. Instead of stepping and striding, astronauts move by gently pushing off walls or using handrails that line the modules like guidance rails in a swimming pool. A light touch of fingertips against a surface sends the body sailing smoothly through the air. A gentle grip on a handrail allows for controlled navigation around corners and through hatches. There is an art to this movement, a skill that takes time to develop. Push too hard, and you find yourself careening across the module, perhaps colliding with equipment or fellow crew members. Push too softly, and you drift with agonizing slowness, taking far longer than necessary to reach your destination. The experienced astronaut learns to apply exactly the right amount of force, to read the geometry of the space around them, to anticipate where their momentum will carry them. In time, movement becomes fluid and beautiful, a continuous flow from handhold to handhold, from module to module, a kind of underwater ballet performed in air. The transformation extends to every aspect of daily life. The routines that govern our existence on Earth, patterns so deeply ingrained that we never think about them, must be completely reimagined in space. Consider how you eat a meal, how you sleep through the night, how you wash your face in the morning. Each of these simple acts, performed thousands of times throughout a lifetime without conscious thought, becomes a challenge and an adventure in microgravity. Daily routines require adaptation, as simple tasks like eating and sleeping are different from anything experienced on the ground. Food preparation and consumption take on new complexity and new delight. On Earth, gravity keeps food on your plate, keeps liquid in your cup, keeps crumbs falling downward where they can be easily swept away. In orbit, none of these assumptions hold true. A dropped morsel of food will not fall to the floor, but will drift through the air, potentially ending up lodged in an air vent or floating into sensitive equipment. A splash of liquid will not splash at all, but will break into dozens of floating globules that scatter in all directions. And so food aboard the station is often sticky or in pouches to prevent it from floating away. Tortillas replace bread because they produce no crumbs. Sauces and condiments come in squeeze bottles. Meals are designed not only for nutrition, but for their behavior in weightlessness, their ability to stay where they are put, their cooperation with the unique demands of the environment. There is something almost childlike about mealtime in space, the way astronauts chase floating food with open mouths, the way they squeeze water from pouches and watch it form wobbling spheres before them. Water itself becomes a source of endless fascination. Released from its container, water forms floating spheres that can be sipped from a straw. These spheres are extraordinarily beautiful, their surfaces curved and perfect, their interiors catching and bending light in mesmerizing patterns. Astronauts describe the joy of watching water behave in ways impossible on Earth, of playing with these liquid sculptures, of discovering that even something as familiar as a drink of water can become magical when the rules of gravity no longer apply. The sphere is the natural shape of liquids in weightlessness. Without gravity to flatten and spread them, without the constant pull that creates the flat surfaces we see in cups and pools and puddles, liquids assume the form that minimizes their surface tension. They become spheres because a sphere is the shape that contains the most volume with the least surface area. It is geometry made visible, physics revealed in shimmering, wobbling balls of water that drift through the air like tiny planets. And when the time comes to sleep, to close one's eyes and surrender to the regenerative embrace of rest, still the gentle physics of zero gravity shapes the experience. Sleeping happens in a sleeping bag tethered to a wall to keep astronauts in place. Without this tethering, a sleeping person would drift through the station propelled by their own breathing, by the tiny movements of dreams, by the circulation of air through the modules. They might wake to find themselves floating in the middle of a laboratory or pressed gently against a window with a view of Earth rolling past below. The sleeping quarters aboard the station are small, phone booth-sized compartments that provide privacy and a sense of enclosure. Within these spaces, astronauts zip themselves into sleeping bags attached to the wall. The orientation matters not at all. One might sleep vertically, horizontally, or at any angle in between. There is no up or down, no right side up or upside down. The only sensation is the gentle embrace of the sleeping bag, the soft support that keeps the body from wandering, the cocoon of warmth and security floating in an infinite void. Many astronauts describe sleep in microgravity as the most peaceful rest they have ever known. Without the pressure of mattress against body, without the need to shift position to relieve compressed joints and muscles, sleep becomes a pure experience of floating relaxation. The body assumes its natural posture, arms drifting slightly forward, spine gently curved, every muscle released from the constant work of fighting gravity. It is perhaps the closest an adult can come to the experience of floating in the womb, suspended and supported and utterly at peace. Let this image carry you now, dear listener, as we pause at the end of our first exploration. Picture yourself floating in that gentle darkness, surrounded by the hum of life support systems, cradled by the vast silence of space. The weight of the world has lifted. The concerns of gravity have dissolved. There is only floating, only breathing, only the slow drift into deeper relaxation. Rest here for a moment. There is so much more to discover, but there is no hurry. The stars will wait. The station continues its endless orbit, and we continue our journey together, one gentle truth at a time. Segment 2. The body in microgravity. The human body is a remarkable vessel, shaped by millions of years of existence on the surface of this planet, molded by the constant presence of gravity into the form we know so intimately. Every system within us, from the beating of our hearts to the structure of our bones, has evolved under the influence of that downward pull. And so when humans venture into space, when they enter the realm of microgravity, their bodies begin to change in ways both fascinating and profound. The absence of gravity changes how fluids behave in the human body. On Earth, gravity pulls our blood and other fluids downward, concentrating them in our legs and lower body. Our cardiovascular system has adapted to this reality, developing mechanisms to pump blood upward against gravity to maintain proper circulation throughout our frame. The heart works harder to push blood toward the brain. Valves in our veins prevent backflow. Our bodies are beautifully engineered machines designed specifically for life under gravitational stress. In space, this carefully calibrated system encounters a new reality. Without gravity's downward pull, blood and other fluids shift toward the upper body and face. The legs, no longer the lowest point of the circulatory system, lose volume as fluids redistribute. The face and upper body receive more blood than they were designed to handle. This fluid shift is one of the most immediate and noticeable effects of entering microgravity, occurring within the first hours of arrival at the station. This fluid shift can cause swelling in the face and upper body. Astronauts notice their faces becoming puffy, their sinuses feeling congested, their features subtly altered by the new distribution of fluids. Fellow crew members sometimes joke about the puffy moon faces that develop in the early days of a mission. It is a harmless change, a temporary adaptation, but it serves as a visible reminder of how profoundly the body responds to its new environment. The eyes, those delicate organs so essential to our experience of the world, are particularly affected by the changes in fluid distribution. Vision changes sometimes occur due to increased pressure on the eyes. The fluid shift can alter the shape of the eyeball, can affect the optic nerve, can change the way light focuses on the retina. Some astronauts return from long missions needing new prescriptions for their glasses, their eyes having been subtly reshaped by months of altered fluid dynamics. Scientists study these changes carefully, seeking to understand the mechanisms at work, developing countermeasures to protect the vision of future astronauts who will spend even longer periods in space. The eyes are windows not only to the soul, but to the health of the body in microgravity. Their changes telling important stories about how humans adapt to life among the stars. Without the constant work of supporting the body's weight, the muscles begin a process of adaptation that resembles, in some ways, a kind of rest. Muscles weaken without the need to support the body's weight. On Earth, even sitting requires muscle engagement, standing requires more. Walking and moving through our days demands the continuous firing of countless muscle fibers. In space, muscles that once worked constantly find themselves with little to do. The body, ever efficient, begins to reduce what it does not use. Astronauts lose up to 10 to 20% of their muscle mass in several weeks without intervention. The large muscles of the legs, the muscles of the back that maintain posture, the muscles that fight gravity with every step, these are the first to diminish. It is the body's way of adapting to its new environment, conserving resources that are no longer needed for gravitational work. The bones tell a similar story of adaptation and loss. Bones also lose mass at a rate of 1 to 2% per month in space. Our skeletons are not the static frameworks we might imagine, but living tissue that constantly rebuilds and reshapes itself in response to the stresses placed upon it. On Earth, the stress of supporting our weight against gravity stimulates bone growth, maintains density, keeps our skeletal system strong. In microgravity, with that stress removed, the bones begin to release their calcium, to thin and weaken like muscles atrophying from disuse. This bone loss is one of the most significant challenges of long-duration spaceflight. The calcium released from bones must be processed by the kidneys, creating potential health concerns. The weakened bones become more susceptible to fracture upon return to Earth. Scientists and doctors work continuously to understand and mitigate these effects, developing exercise programs and potential pharmaceutical interventions to preserve skeletal health in space. And so exercise is crucial to maintain muscle and bone strength. It is not optional, not a hobby or pastime, but a medical necessity, a prescription for health that astronauts follow with dedication and discipline. The daily exercise regimen is one of the most important activities aboard the station, taking priority over all but the most critical work. Astronauts use treadmills and stationary bikes with special restraints. The treadmill looks much like those found in any gym on Earth, but it is equipped with a harness system that holds the astronaut down against the running surface. Without this restraint, pushing against the treadmill would simply send the astronaut floating away. The harness applies pressure that simulates a portion of the body's weight, allowing the running motion to stress muscles and bones in something resembling normal conditions. The stationary bike works similarly, with astronauts strapped to the seat, their feet clipped to the pedals, their bodies held in place so that the effort of cycling is not wasted pushing them around the module. The resistance exercise machine uses vacuum cylinders to create forces that mimic weightlifting, allowing astronauts to perform squats and bench presses and other strength-building exercises without the need for actual weights. Without gravity, astronauts must exercise for about 2 hours each day. This is not leisure time but medical time, as essential as any other health maintenance activity. The 2 hours are split between cardiovascular work on the treadmill and bike and resistance training on the exercise machine. It is a significant portion of each day devoted simply to counteracting the effects of the environment, to maintaining the body's capability to return to Earth's surface. Despite these countermeasures, changes continue throughout the cardiovascular system. The heart and blood vessels become weaker over time. The heart, that tireless muscle that has beaten billions of times throughout your life, finds its workload reduced in microgravity. Without gravity to fight against, without the need to pump blood upward through the body, the heart begins to atrophy like any underused muscle. It grows slightly smaller, its walls becoming thinner. Blood pressure regulation changes in microgravity. The baroreceptors, those sensors in our blood vessels that detect pressure and signal the heart to adjust its output, become recalibrated to the new normal of even fluid distribution. When astronauts return to Earth, their cardiovascular systems must rapidly readjust to the sudden return of gravitational stress, a process that can cause dizziness, fainting, and difficulty standing upright. The sinuses and nasal passages feel the effects of fluid shift throughout the mission. Nasal congestion is common due to fluid shifts. Astronauts describe feeling as though they have a permanent head cold, their sinuses swollen, their voices slightly altered by the chronic stuffiness. It is a minor inconvenience, but a persistent one, a constant reminder of the body's adjustment to its new environment. The tissues throughout the face and upper body become swollen with the redistributed fluids. Tissues in the face and upper body become swollen, giving astronauts that characteristic puffy appearance that distinguishes space travelers from their Earth-bound photos. The swelling is harmless but noticeable, a visible manifestation of the invisible forces at work within the body. Deep within the skull, the inner ear struggles to make sense of its new reality. The inner ear, which helps with balance, is affected by weightlessness. The tiny organs that detect acceleration, that tell us which way is up and which way is down, find themselves without a gravitational reference. Some astronauts experience space motion sickness in their first days in orbit, their brains struggling to reconcile conflicting signals from eyes and inner ear, their vestibular systems searching for a down that no longer exists. In time, the brain adapts, learning to ignore the confusing signals from the inner ear, relying more heavily on visual cues for orientation. But the adaptation is never complete, and returning astronauts must readjust to Earth's gravity, must relearn to trust their inner ear's signals about which way is up. Vision can be altered, sometimes temporarily, due to pressure changes. Beyond the fluid-related changes already mentioned, some astronauts experience more significant visual disturbances that persist after return to Earth. Scientists call this syndrome SANS, Spaceflight-Associated Neuroocular Syndrome, and it remains one of the most studied and concerning health effects of long-duration spaceflight. The digestive system, too, responds to the weightless environment in ways that can be uncomfortable. flatulence and constipation are more frequent in space. Without gravity to assist the movement of food and waste through the intestinal tract, digestion can become sluggish. Astronauts must pay careful attention to their diet, to hydration, to the timing of meals, all in service of maintaining digestive health in an environment where the body's normal processes are altered. The blood itself changes in response to microgravity. The production of red blood cells is disrupted, causing what is known as space anemia. The body, sensing that blood is distributed differently, that the total volume needed to fill a body in space is less than on Earth, reduces its production of new red blood cells. Astronauts return with lower red blood cell counts, their bodies needing time to rebuild what was lost. Beyond the direct effects of weightlessness, space itself poses unique hazards. Astronauts are exposed to higher levels of ionizing radiation. The Earth's atmosphere and magnetic field shield us from most cosmic radiation, from the particles streaming through space from the Sun and from distant galactic sources. In orbit, outside this protective cocoon, astronauts receive radiation doses many times higher than people on Earth's surface. The long-term effects of this radiation exposure are still being studied. Cancer risk may be elevated, cellular damage may accumulate. The eyes and central nervous system may be particularly vulnerable. It is one of the many challenges that must be addressed before humans can safely venture on the long journeys to Mars and beyond. And what of the brain itself, that most complex organ, that seat of consciousness and thought? Space travel may affect the structure of the human brain. Studies of astronauts before and after spaceflight have revealed subtle changes in brain structure, shifts in the distribution of cerebrospinal fluid, alterations in the white matter that connects different brain regions. The significance of these changes is not yet fully understood, but they remind us that every part of the body responds to the profound experience of leaving Earth. Rest now with this knowledge, dear listener. Your body, lying still in the gentle embrace of Earth's gravity, is perfectly adapted to this moment, to this place. The heart beats at its accustomed rate. The fluids flow in their familiar patterns. The bones and muscles maintain their earthly strength. You are home in the environment for which evolution shaped you, cradled by the very force that shapes all life on this planet. Breathe slowly. Let the weight of your body settle into comfort. And as we continue our journey through the gentle physics of the space station, carry with you this appreciation for the remarkable adaptability of human life, for the courage of those who venture beyond our world, for the resilience of bodies that can thrive even among the stars. Segment 3. The laboratory among the stars. High above the surface of our world, the International Space Station serves a purpose beyond simply housing human beings in the void. It is a laboratory of unprecedented capability, a place where experiments impossible on Earth can unfold in the unique conditions of microgravity. Scientists from nations around the globe send their investigations to this orbital outpost, seeking answers to questions that can only be explored where gravity's influence is removed from the equation. The ISS is a laboratory for studying the effects of microgravity. Within its modules, countless experiments run continuously, some automated, some requiring the careful attention of astronaut scientists. Research spans disciplines from biology to physics, from materials science to human physiology. Each investigation takes advantage of what the station uniquely offers: a stable, long-term environment of weightlessness that cannot be replicated by any facility on Earth. Experiments on the ISS help us understand how living things adapt to space. Plants are grown in carefully controlled chambers, their roots and shoots observed as they seek direction in an environment without the gravitational cues that normally guide their growth. Microorganisms are cultured and studied, their behavior in microgravity revealing insights about fundamental biological processes. Animal research, though limited, provides data about how complex organisms respond to the space environment. The human astronauts themselves are both experimenters and experimental subjects. Their bodies, monitored throughout their missions, provide invaluable data about human adaptation to space. Blood samples, medical imaging, cognitive tests, physical examinations all contribute to a growing body of knowledge about how people can live and work beyond Earth for extended periods. Physical systems behave differently in zero gravity in ways that reveal the fundamental principles underlying their behavior. Processes that are affected by gravity on Earth, processes where the weight of materials influences their behavior, can be observed in pure form in space. The results often surprise researchers, revealing aspects of physical law that gravity obscures or complicates. Fluids form perfect spheres due to surface tension. On Earth, the weight of a liquid flattens it against whatever surface contains it. Water takes the shape of its vessel, filling the bottom of cups and pools and oceans. In space, freed from this flattening influence, liquids reveal their true nature, the cohesive forces between molecules pulling them into spheres, the shape that minimizes surface energy, the form that surface tension alone would create. Scientists study these fluid behaviors for insights into industrial processes, into fundamental physics, into the way liquids and gases interact in the absence of buoyancy and convection. The knowledge gained has applications in fields from medicine to manufacturing, from space propulsion to everyday consumer products. Fire too transforms in the absence of gravity. Flames burn differently, forming round balls instead of flickering shapes. On Earth, the flame of a candle rises and dances because hot combustion gases are less dense than cooler air, causing them to rise buoyantly upward, drawing fresh oxygen in from below. This convection creates the teardrop shape, the flickering motion, the familiar form of earthly fire. In space, there is no buoyancy. Hot gases do not rise because there is no up. A flame in microgravity burns as a sphere, consuming oxygen equally from all directions, glowing with an eerie, steady light quite different from terrestrial fire. These spherical flames burn more efficiently in some ways, their uniform geometry allowing more complete combustion. Scientists study space flames to understand combustion fundamentals, seeking knowledge that can improve fire safety both in space and on Earth, that can enhance engine efficiency, that can inform our understanding of chemical reactions in extreme environments. Fire, one of humanity's oldest tools, still has secrets to reveal when observed in the laboratory of weightlessness. Life itself responds to the absence of gravitational cues in remarkable ways. Plants grow in unusual directions without gravity to guide them. On Earth, roots grow downward and shoots grow upward in response to gravity, a phenomenon called gravitropism that has guided plant development for hundreds of millions of years. In space, deprived of this guidance, plants must rely on other cues, light and moisture, and their own internal programming. Researchers observe how plants adapt, how their cells and tissues respond to the novel environment, how growth patterns change when the gravitational compass is removed. The knowledge gained informs our understanding of plant biology and also prepares us for the day when crops will need to be grown on long space voyages or in permanent settlements on other worlds. Materials processing takes on new possibilities in microgravity. Crystals grow more perfectly in microgravity. On Earth, gravity causes convection in the melts and solutions from which crystals form, introducing defects and irregularities into crystal structure. In space, with convection suppressed, crystals can form with extraordinary purity and regularity. Protein crystals grown in space allow scientists to determine molecular structures with unprecedented precision, advancing our understanding of biology and accelerating drug development. Semiconductor crystals might be manufactured in orbit with properties impossible to achieve on Earth. The potential for space-based materials processing remains largely untapped, waiting for the day when such manufacturing becomes economically viable. The lack of gravity makes some industrial processes more efficient. Mixing and combining materials, manufacturing metals and alloys, producing glasses and ceramics, many industrial processes are influenced by gravity in ways that limit their outcomes. In space, these limitations are removed. Materials can combine and solidify without settling or stratification, without the influence of buoyancy, without the complication of convection currents. Researchers on the station conduct experiments that point toward future space industries, toward the possibility of manufacturing in orbit products that cannot be made as well on Earth. It is a vision of a future economy that extends beyond our planet, that takes advantage of the unique conditions space offers. The ISS provides a unique environment for scientific discovery. No laboratory on Earth can replicate the continuous weightlessness the station provides. Drop towers and parabolic flights offer only seconds or minutes of microgravity. Only a permanent space station allows experiments to run for days and weeks and months, allows researchers to observe long-term effects, allows the patient accumulation of data that science requires. Every experiment conducted on the station builds upon those that came before, contributes to a growing understanding of how the universe works, prepares us for future ventures deeper into space. Research on the ISS helps prepare for long-term space missions. The knowledge gained about human health in microgravity, about life support systems, about materials and processes, all of this feeds into planning for journeys to the Moon and Mars, for eventual human expansion beyond Earth orbit. The station is a stepping stone, a testbed, a training ground. It is humanity's toe dipped into the cosmic ocean, our first permanent presence beyond the atmosphere, our practice for the greater journeys that await. Every system tested on the station every medical protocol refined, every piece of equipment proven, brings those future missions closer to reality. And through it all, the gentle physics of zero gravity shapes every investigation, influences every result, offers insights available nowhere else. The station orbits in silence, its solar panels tracking the sun, its modules filled with the quiet hum of equipment, its crew moving through their days of research and discovery. It is perhaps the most remarkable laboratory ever built, a testament to what humanity can achieve when nations cooperate in the pursuit of knowledge. Rest now, dear listener, with the image of this laboratory among the stars. Imagine the astronauts floating before their experimental racks, recording data, adjusting parameters, contributing to the slow accumulation of knowledge that advances our species. Science moves forward one careful observation at a time, one experiment building upon another, each generation inheriting and extending what came before. The pursuit of knowledge is itself a kind of floating, a patient drift toward understanding, a willingness to follow evidence wherever it leads. In the laboratory of the space station, humans engage in this ancient pursuit in an entirely new environment, pushing against the boundaries of what we know, expanding the horizons of possibility. Let this peaceful image carry you deeper into rest. The scientists work through their quiet days, the experiments continue their patient progress, and the station drifts on, a beacon of curiosity orbiting above a sleeping world. Segment 4. The Art of Movement. To move through the International Space Station is to experience a form of locomotion unknown to all previous generations of humanity. It is neither walking nor swimming nor flying, yet it partakes of elements of each. It is a new art, a new skill, a new way of inhabiting space that astronauts must learn from the moment they arrive and continue to refine throughout their stay. Movement in zero gravity feels like flying. Every child who has dreamed of soaring through the air, of swooping and gliding like a bird, catches a glimpse of that dream when they watch astronauts move through their orbital home. The movements are smooth and continuous, unburdened by the need to maintain contact with the ground, freed from the constant negotiation with gravity that shapes every motion we make on Earth. With the gentlest of pushes, astronauts can float from one end of the station to the other. The initial push, applied with feet or hands or fingertips, sets the body in motion. From that point on, no further effort is required. The body sails through the air, maintaining its velocity until something, a wall, a handrail, a fellow crew member, interrupts its progress. It is motion distilled to its essence, Newton's first law made visible. An object in motion remaining in motion until acted upon by another force. There is a particular pleasure in this kind of movement that astronauts often struggle to describe. It is the closest thing to effortless locomotion that humans have ever experienced. No muscles burning with exertion, no joints bearing weight, no cardiovascular system straining to supply energy to working limbs. Just smooth, silent sailing through a three-dimensional space, the body floating in perfect relaxation even as it travels from place to place. Objects drift slowly unless anchored or caught. This is the other side of the coin of easy movement. In an environment where everything floats, nothing stays where you put it unless actively secured. A pen released from the hand does not fall to a desk but hangs in the air, slowly rotating. perhaps beginning a lazy drift toward an air vent that will carry it to some distant corner of the station. Tools and equipment must be secured to prevent them from floating away. The station is equipped with various restraint systems, Velcro patches on surfaces where items can be temporarily stuck, bungee cords and straps for larger equipment, magnetic strips for metal tools. Without these systems, the station would quickly become chaotic, important items drifting off to lodge in inaccessible spaces, crew members spending their days searching for escaped equipment. The discipline of securing objects becomes second nature to experienced astronauts. Every time they release something, their hands automatically move to attach it to a surface or restraint. Every time they need a tool, they know exactly where it should be because they have been meticulous about returning it to its proper place. The station may look cluttered to the uninitiated eye, but there is order in that clutter, a place for everything and everything in its place. The organizational discipline that makes life possible in zero gravity. Daily chores require new techniques, such as using magnetic or Velcro surfaces. Tasks that are trivially simple on Earth become small puzzles to be solved in microgravity. How do you eat soup when it won't stay in a bowl? How do you write notes when paper floats away and pens drift from your hand? How do you examine a piece of equipment that won't sit still on a work surface? The answers often involve creative use of the restraint systems that permeate the station. Food is eaten from pouches or with magnets and straps to hold containers in place. Notes are written on Velcro-backed tablets or entered directly into computers. Equipment is examined in specially designed glove boxes or while tethered to the work area. Every ordinary task has its zero-gravity solution, its adaptation to the unique demands of the environment. Personal hygiene is different, with waterless shampoos and special toothpaste. The simple act of washing oneself, so routine on Earth, becomes an elaborate procedure in space. Water cannot be poured over the body. It must be applied in careful, controlled quantities and then captured before it escapes into the air. Shampoos are formulated to require no rinsing, absorbing into the hair and scalp without the need for flowing water. Toothpaste is designed to be swallowed rather than spit, eliminating the problem of disposing of the foamy residue. Astronauts clean their bodies with damp cloths, wiping away the day's accumulation of sweat and dead skin cells. They pay particular attention to hygiene in an environment where sweat does not evaporate as efficiently, where small droplets of moisture can linger and accumulate. Showers are not possible. Astronauts use wet wipes and no-rinse products. The luxury of standing beneath cascading water, of feeling its warmth wash away the cares of the day, is not available aboard the station. Instead, astronauts become expert at the art of the space bath, using minimal water and specialized products to maintain cleanliness and comfort. Many astronauts report that they adapt quickly to these hygiene limitations, that what seems at first a great inconvenience soon becomes simply the way things are done. The human capacity for adaptation is remarkable. Our ability to normalize even the strangest circumstances, allowing us to feel at home in the most alien environments. Waste management presents its own challenges and solutions. Waste is collected and stored in sealed containers. The station's toilet, a marvel of engineering necessity, uses airflow rather than gravity to direct waste into collection receptacles. Solid waste is compressed and stored for disposal. It will eventually burn up during atmospheric re-entry of a departing cargo vessel. Liquid waste is collected and processed, the water reclaimed for reuse. The air too requires constant attention and management. The air is constantly filtered to keep it clean and breathable. In the enclosed environment of the station, contaminants would quickly accumulate without active removal. Carbon dioxide exhaled by the crew, trace gases released by equipment and experiments, particles and droplets floating in the air, all must be captured and processed. Filters remove particulates from the air. Chemical scrubbers extract carbon dioxide. The atmosphere is constantly circulated, monitored, maintained within the narrow parameters that support human life. It is a never-ending task, the breathing of the station itself, the inhalation and exhalation that keeps the crew alive. The ISS is a closed system, recycling air and water. What would be waste in a less constrained environment becomes precious resource in the isolation of orbit. The moisture exhaled by the crew is captured and purified. Urine is processed and the water recovered. Sweat that evaporates into the air is condensed and reclaimed. Every drop of water is precious. Every molecule cycled through the life support systems again and again. This recycling extends beyond water to other materials as well. Food packaging is carefully designed to minimize waste. Experiment materials are reused where possible. The station strives toward efficiency, toward minimizing the constant resupply from Earth, toward the kind of closed-loop sustainability that will be essential for longer missions far from home. Through it all, through all the challenges and adaptations, astronauts find joy in the experience of living in zero gravity. The difficulties become routines, the routines become normal, and what remains is the pure wonder of floating, of moving without effort, of inhabiting a world where up and down are merely suggestions, and the body is free from the constant burden of its own weight. Let this sense of adaptation settle over you now, dear listener. Wherever you are resting, your body has adapted to its position. Your breathing has found its rhythm. Your muscles have released their tension. You too are finding comfort in your environment, settling into the routines of rest, normalizing the transition from wakefulness to sleep. Float now in the darkness behind your closed eyes. The art of movement in your rest is simply stillness, the quiet drifting of consciousness toward dreams. There is no need to go anywhere, no need to do anything. Simply float, simply drift, simply be. Segment 5. The psychology of floating. The experience of weightlessness touches not only the body, but the mind. To float is to experience a fundamental shift in one's relationship with the physical world, a liberation from constraints so constant that we normally never notice them. This shift has profound psychological dimensions that astronauts have described in countless memoirs and interviews, each trying to capture in words an experience that transcends ordinary language. The sensation of weightlessness can be disorienting at first. Humans are creatures of gravity. Our entire perceptual system built around the assumption of a constant down. Our eyes expect the world to have a floor and a ceiling. Our inner ear expects to report which way is up. Our proprioceptive sense, the awareness of our body's position in space, expects to feel the pressure of surfaces against flesh, the weight of limbs, the pull of gravity on every tissue. In microgravity, all these expectations are violated. The visual world may have walls in every direction, none of them clearly the floor. The inner ear reports nothing useful, its tiny gravity-sensing organs floating uselessly in their chambers. The body feels strangely ungrounded, strangely light, strangely present in a new way that takes time to understand and accept. Astronauts sometimes feel like they are upside down, even when not. The brain, searching for familiar reference points, sometimes seizes on the wrong cues, interpreting a scene based on the orientation of equipment or the position of a crewmate rather than any real vertical reference. An astronaut might suddenly feel certain that they are hanging from the ceiling, their colleague somehow standing normally on what the astronaut perceives as the floor above them. These perceptual confusions pass with time. The brain adapts over time to the new environment. Within days or weeks, most astronauts report that their brains have essentially given up on the concept of up and down, accepting the three-dimensional freedom of their new environment. They learn to orient themselves by the layout of the station's modules rather than by any gravitational sense, to navigate by memory and visual landmarks rather than by feeling which way is down. This neural adaptation is itself remarkable, a demonstration of the brain's plasticity, its ability to rewire itself to function in environments our evolution never anticipated. The same brain that keeps us upright and oriented on Earth can, with time, adapt to a world where those abilities are meaningless. When evening comes aboard the station, when the work of the day is done and it is time for sleep, the experience of rest takes on qualities unknown on Earth. Sleeping in zero gravity is peaceful, with no pressure on the body. There is no mattress pressing against hips and shoulders, no pillow bunching beneath the head, no need to shift position to relieve the discomfort of prolonged pressure on any part of the body. The sleeping astronaut simply floats within their sleeping bag, the soft fabric providing just enough enclosure to create a sense of security without any of the pressure points that make earthbound sleep uncomfortable. The spine assumes its natural curve, each vertebra floating in its proper relationship with its neighbors, freed from the constant compression of gravity. Astronauts often say sleeping feels like floating on a cloud. The metaphor is apt, capturing the sense of supported lightness, of being held by something infinitely soft and yielding. Many astronauts report that the quality of their sleep in space is exceptional. The absence of pressure points and the reduction of gravitational stress, allowing for deeper, more restorative rest. The dream life of astronauts is affected as well. Dreams can be more vivid in space. Some astronauts report dreams of flying, their sleeping brains processing the waking experience of floating and translating it into nocturnal visions of soaring through vast spaces. Others dream of home, of the weight of familiar places, their minds rehearsing the return to gravity even as their bodies rest in weightlessness. The boundary between waking and sleeping can feel different in space, the gentle floating of wakefulness blending smoothly into the gentle floating of dreams. Some astronauts describe drifting gradually into sleep without a clear transition. One moment awake and floating, the next moment dreaming and floating still. Beyond the necessities of work and rest, there is time in space for play, for the pure joy of movement in an environment that makes many things possible that would be impossible on Earth. The lack of gravity allows for creative forms of movement and play. Astronauts take time to enjoy their unique environment, to play games adapted for microgravity, to share with audiences on Earth the wonder of what their bodies can do in weightlessness. Astronauts can do flips and spins with minimal effort, a gentle push from a wall, a slight tucking of the body, and the astronaut rotates through the air once, twice, as many times as their momentum allows. A twist of the torso sends the body spinning like a figure skater, but without the need for ice or the constraint of maintaining contact with a surface. The air itself becomes a medium for acrobatics, for dance, for the pure expression of physical joy. Everyday objects become toys in zero gravity. A ball of water becomes a shimmering sphere to push and probe. A handful of candy becomes a floating constellation to be caught one piece at a time by an open mouth. A pen becomes a spinning spacecraft. A crumpled piece of paper becomes a lazy comet drifting through the module. The world becomes a playground when the rules of gravity no longer apply. The experience of floating is often described as joyful and freeing. There is something deeply liberating about escape from gravity, something that touches the human spirit in ways that are difficult to articulate. Astronauts speak of the pure happiness of floating, of the childlike delight that returns each time they push off and sail through the air, of the sense of freedom that comes from moving in 3 dimensions without constraint. This joy does not diminish with time. Even astronauts who have spent months in space report that the experience of floating remains wonderful, that the novelty never entirely fades, that there are moments throughout even the most routine day when the strangeness and beauty of their situation strikes them anew. To float is to be reminded constantly that you are somewhere extraordinary, living an experience that almost no humans have ever known. And yet alongside the joy, there is also a kind of peace. The floating itself is serene, the motion through the station quiet and calm. There is no stomping of feet, no jarring of joints, no effort of locomotion. Movement in zero gravity is inherently gentle, inherently smooth, inherently relaxing in its effortlessness. This serenity pervades life aboard the station. The environment is quiet, the vacuum of space permitting no sound to penetrate from outside. The work proceeds at a measured pace, the crew moving through their tasks with the calm efficiency of people who have learned to float through their days in the most literal sense. There is stress, certainly, and pressure, and the challenges of complex technical work in a dangerous environment. But there is also peace, the peace of the floating body, the peace of the quiet station, the peace of distance from the busy complications of Earth. Let this peace settle over you now, dear listener. You need not be in space to experience the serenity of release. Here, in your resting place, you can let go of the weight of the day. You can allow your mind to float, your thoughts to drift, your awareness to ease into the gentle current that carries you towards sleep. The astronauts in their orbital home have found peace far above the world. You can find it here in the quiet of this moment, in the soft darkness of closed eyes, in the slow rhythm of breath that needs no effort, in the peaceful floating of consciousness toward dreams. Rest now, float now, all is well. Segment 6. The mechanics of orbit. The International Space Station does not drift aimlessly through the void, but follows a precise mathematical path, a trajectory determined by the same laws of physics that govern the motions of moons and planets. Understanding this path, this delicate balance of forces, reveals the elegant mechanics that make the space station's mission possible. The ISS orbits Earth at about 17,500 miles per hour. This number is almost impossible to comprehend in human terms. A jet airplane might cruise at 500 or 600 miles per hour. A bullet leaves a rifle barrel at a few thousand miles per hour. The space station moves at speeds that dwarf any vehicle most humans will ever experience, racing around our planet faster than anything in our everyday lives. And yet, to someone aboard the station, there is no sensation of this tremendous speed. The windows show Earth rolling slowly past below, the continents drifting by at what seems a peaceful pace. There is no wind, no vibration, no sense of hurtling through space at hypersonic velocity. The speed is real, but the experience is one of serenity. At this velocity, it completes one orbit every 90 minutes, experiencing 16 sunrises and sunsets each day. The sun rises over the curved horizon of Earth, blazes across the sky, and sets again in less than an hour. The cycle repeats again and again, day and night flickering past like the frames of a film, the station slipping from daylight to darkness and back to daylight in the time it takes to eat a meal on Earth. Astronauts report that this rapid cycling of light and dark takes some adjustment. Sleep schedules must be maintained artificially, decoupled from the meaningless succession of orbital days and nights. The crew operates on coordinated universal time, their schedule matched to the workday of mission control in Houston, their artificial day imposed on the chaos of 16 daily sunrises. The rapid orbit keeps the station in a constant state of freefall. This is the key to everything, the fundamental fact that explains the floating astronauts, the spherical water droplets, the flames that burn in balls. The station falls toward Earth every moment of every day, its trajectory a curved path that bends constantly toward the planet's center. But the surface of Earth curves away as well, falling away beneath the station's forward motion. For every distance the station falls toward Earth, the surface drops an equal amount, maintaining the separation between spacecraft and ground. It is like running around the inside of a giant bowl so fast that you never slide down the sides, your forward motion precisely balancing the slope that would otherwise carry you to the bottom. The feeling of weightlessness is a direct result of orbital motion. Everything inside the station falls together at the same rate in the same direction. The station falls and the astronauts fall, and the equipment and experiments and droplets of water all fall together. Because they all fall together, none of them presses against any other. There is no weight because there is nothing to push against, nothing to create the sensation of pressure that we call heaviness. It is perhaps the most elegant explanation in all of physics, this connection between orbital mechanics and weightlessness. The station does not achieve zero gravity by rising above gravity's reach, but by surrendering to gravity completely, by falling freely, by allowing gravity to have its way unresisted. Weightlessness is not the absence of gravity, but the perfect yielding to it. The ISS is not escaping Earth's gravity, but is falling around it. This distinction is important and often misunderstood. The station has not reached some place where gravity does not exist. There is no such place in the universe. Gravity extends infinitely, the attraction between all massive bodies reaching across the cosmos without limit. The station merely travels in such a way that gravity's effects manifest as orbital motion rather than falling to the ground. The station's path is a delicate balance between gravity and speed. Too slow, and the station would spiral inward, eventually re-entering the atmosphere and burning up. Too fast, and it would spiral outward, escaping Earth's grip and drifting away into the solar system. The actual speed is precisely what is needed to maintain a stable orbit at the station's altitude. This balance must be actively maintained. The outer wisps of Earth's atmosphere extend even to the station's altitude, creating a slight drag that gradually slows the spacecraft. Without correction, this drag would eventually cause the station to fall. Periodically, visiting spacecraft fire their engines to boost the station's speed, lifting it back to its proper orbit, counteracting the effects of atmospheric drag. Without this balance, the ISS would either crash into Earth or drift into space. The delicate equilibrium that allows the station to exist where it does is maintained by continuous attention, by the work of engineers and controllers on the ground, by the careful calculations that determine when and how to adjust the station's velocity. It is a testament to human precision that this balance is maintained year after year, that the station continues its endless fall without ever reaching the ground. The gentle physics of zero gravity allows for unique scientific experiments. The orbital environment provides something available nowhere else, a location where experiments can proceed for extended periods without the influence of gravity. This freedom from gravitational effects enables research impossible on Earth, from the behavior of fluids to the growth of crystals to the functioning of the human body. Astronauts use specialized equipment to maintain physical health. The exercise machines, the medical monitoring devices, the pharmaceutical countermeasures, all exist because the orbital environment, for all its scientific value, is challenging for human bodies. The very weightlessness that makes the research possible also strains the systems of the astronauts who conduct it. Life aboard the ISS is a continuous adaptation to microgravity. There is no moment when the adaptation is complete, when the astronauts can simply live as they would on Earth. Every day brings small challenges and reminders that this environment is fundamentally different from the one in which they evolved. And yet the adaptation proceeds, the human capacity for adjustment proving equal to even this most alien of homes. Consider the mathematics of it, dear listener, as you rest. The station's orbit is an ellipse, a shape defined by simple equations, a curve that the ancient Greeks understood and that Newton showed governed all orbital motion. The speed at every point in the orbit is determined by these equations, the position at every moment predictable centuries in advance. There is comfort in this predictability, in knowing that the station follows a path laid out by the laws of physics themselves. The universe operates according to principles we can understand, equations we can write, predictions we can verify. The station's orbit is a demonstration of this knowability, a proof that the cosmos makes sense, that the machinery of nature runs with beautiful precision. And within this precise mechanism, human beings float and work and sleep. The vast mathematics of orbital mechanics reduces for the astronauts inside to the simple experience of weightlessness, of floating through their days, of living in a world where gravity's constant pull has been transformed into something new. Let the image of that orbital path carry you now, a great circle around the Earth, endless and smooth. The station rides that path without effort, carried by the same forces that spin galaxies and kindle stars. You ride your own path tonight, the arc of rest that carries you from wakefulness towards sleep, your own trajectory as natural and inevitable as the station's orbit. Float along that path. The mathematics takes care of itself. The physics runs smoothly in the background. All you must do is let go. Allow yourself to fall into rest, surrender to the gentle mechanics that carry you where you need to go. Segment 7. Home among the stars. For all its technical complexity, for all its scientific purpose, the International Space Station is also simply and profoundly a home. Human beings live there, not just visit, not just work, but make their lives in the modules and nodes and cupolas of that orbital outpost. They eat and sleep and laugh and dream 250 miles above the surface of their world, and in doing so, they make that strange place their own. The ISS is a home for astronauts as well as a laboratory. The distinction matters. A laboratory is a place of work, a facility designed for specific tasks, a location one visits and then leaves. A home is something different. A home is where one lives, where one rests, where one's private thoughts and personal routines unfold. The station is both these things, simultaneously workplace and living space. Astronauts eat, sleep, work and relax in the same floating environment. There is no commute between home and office, no separation between personal and professional space. The modules where experiments are conducted are the same modules where meals are eaten, where exercise is performed, where crew members gather to watch movies on their rest days. The distinctions that structure life on Earth dissolve in the unified environment of the station. Every aspect of daily life is influenced by microgravity. From the moment of waking to the moment of sleep, from the first meal to the last task of the day, the absence of gravity shapes how things are done. There is no unconscious action, no activity so routine that it can be performed without awareness of the unique environment. Microgravity demands attention, demands adaptation, demands creativity in solving the problems it creates. The lack of gravity changes the way food is prepared and consumed. Meals are important events aboard the station, social occasions as well as nutritional necessities. Crew members gather at mealtimes to share food and conversation, to maintain the social bonds that are essential for psychological health during long-duration missions. The food itself may come from pouches and tubes, but the fellowship is as real as any dinner party on Earth. Water is precious and carefully recycled. Every drop that enters the station must be used and reused, purified and recycled, cycled through the life support systems until it has served its purpose many times over. Astronauts are conscious of their water use in ways that most people on Earth never consider, aware that every sip they take has been reclaimed from the air they breathe, from the sweat of their exercise, from sources they prefer not to contemplate too closely. The air is filtered and refreshed to maintain a healthy environment. The atmosphere inside the station is a carefully balanced mixture, monitored continuously, adjusted when necessary, maintained within narrow parameters that support human life. The air has no natural source of refreshment. There are no open windows, no breezes carrying the scent of rain or flowers. Every breath the crew takes comes from systems designed and built and monitored by human engineers. Waste management is a critical part of life on the ISS. The station produces waste like any human habitation, but there is no garbage truck to carry it away, no sewage system to flush it into oblivion. Waste must be stored, contained, eventually disposed of on departing spacecraft that will burn up in the atmosphere. The mundane necessities of waste disposal become matters of engineering and logistics in the confined environment of the station. Despite these challenges, the station is designed to be as comfortable as possible in zero gravity. The design teams who created the modules understood that humans would be living there for months at a time. That psychological comfort matters as much as physical functionality. The station includes spaces for privacy, for relaxation, for the personal needs of its crew. Astronauts have personal spaces for privacy and relaxation. Each crew member has a small compartment they can call their own, a phone booth-sized space where they can close a door, be alone, pursue personal activities without the constant presence of colleagues. These spaces are tiny by earthly standards, but in the goldfish bowl environment of the station, they are precious refugees. In these personal spaces, astronauts keep photographs of family and friends, small mementos from home, the personal items that remind them of the world they left behind. They retreat there to read, to write, to video call with loved ones, to simply be alone with their thoughts in an environment where solitude is a rare luxury. And then there is the view. The view of Earth from the ISS is a constant source of wonder. Of all the experiences of spaceflight, astronauts consistently report that seeing Earth from above is the most profound, the most moving, the most difficult to adequately describe. The cupola module, with its large windows facing the planet, has become a favorite gathering place for crew members seeking the contemplative experience of gazing down at their home world. The view changes constantly as the station orbits. Oceans and continents roll past, their familiar shapes somehow transformed by the perspective of altitude. Weather systems swirl in vast spirals, their scale apparent only from space. Cities glitter at night, their lights tracing the coastlines and river valleys where human civilization has concentrated. The thin blue line of the atmosphere arcs along the horizon, fragile and beautiful, the only barrier between the warmth of Earth and the cold of space. Astronauts speak of the overview effect, a cognitive shift that occurs when seeing Earth from space. The borders that seem so important from the surface disappear. The planet appears as a single unified whole, a living system of which all humans are a part. This perspective can be transformative, changing how astronauts think about their home world, about the connections between all people, about the importance of protecting the only planet we have. The gentle physics of zero gravity makes everyday activities serene and effortless. There is a calmness to life in space that comes from the absence of gravitational effort. Moving requires no strain, holding position requires no energy, simply being requires no work against the constant pull of the ground. This effortlessness can translate into a kind of peace, a baseline relaxation that underlies even the most demanding work. Astronauts can move with minimal effort, gliding from one module to another. The movement itself is a pleasure, a reminder with every transition that they are somewhere extraordinary. There is time in the course of busy workdays to appreciate the strangeness of floating through a corridor, of arriving at a destination without having taken a single step in the traditional sense. The absence of gravity allows for unique forms of exercise and play. Crew members find moments throughout their days for the small joys of weightlessness, for the games and experiments that make life in space not just endurable, but enjoyable. These moments of play are not mere indulgences, but essential for mental health, for maintaining the positive attitude that allows humans to thrive in challenging environments. The ISS is a place of scientific discovery and human adaptation. Both purposes are served simultaneously, each supporting the other. The science conducted on the station advances human knowledge. The human presence makes that science possible. The adaptation of the crew demonstrates what humans can achieve. The research they conduct prepares the way for future achievements. Life aboard the ISS is a testament to the resilience and ingenuity of humans. That people can live in such an environment at all is remarkable. That they can thrive there, conduct important research, maintain their health and sanity over months of isolation is a tribute to human capability. The station is a demonstration of what our species can accomplish when we set our minds to a goal. Rest now with the image of this home among the stars, dear listener. The astronauts in their floating refuge have made a life in the most unlikely of places. Their home is strange by earthly standards, but it is a home nonetheless. A place of meals and sleep and work and rest. A place where humans have found ways to live and even flourish. Your home tonight is wherever you are resting. The place where your body has settled into comfort, where your mind is easing towards sleep. Like the station, it contains everything you need for this moment, this transition from day to night, this gentle passage into dreams. The station orbits on through the darkness. You rest where you are, equally at home, equally at peace. The universe contains multitudes, and among them are these two small homes, one floating above the earth, one resting upon it, both cradling human life through the quiet hours. Segment 8. The Poetry of Weightlessness. There comes a moment in every astronaut's experience when the practical realities of space travel give way to something deeper, something harder to name. It is not merely the science or the engineering or the medical challenges that define life in orbit. It is something more intangible, more like poetry than physics, more like wonder than work. It is the experience of floating itself, and what that experience means for the human spirit. The gentle physics of zero gravity shapes every aspect of life on the ISS. We have spoken of this throughout our journey tonight, but now let us rest with this truth more fully. Let it settle into understanding, not just of the mind, but of the heart. Gravity is so constant in our lives that we never think of it, never notice its presence any more than we notice the air we breathe. To have it removed, even partially, even in the transformed way of orbital freefall, is to experience a kind of revelation. The experience of floating is a peaceful reminder of the wonders of space. Astronauts report that the sensation never entirely becomes routine. Even after months in orbit, even when the novelty of everything else has faded, there are moments when the simple fact of floating strikes them anew, when they pause in the midst of some ordinary task to notice that they are hovering in mid-air, that their body hangs suspended with no visible support, that the rules that have governed their entire lives have been rewritten. These moments of wonder are important. They remind the astronauts why they are there, what they have given up to be there, what they are part of. The wonder keeps the experience alive, keeps it from becoming merely another job in another workplace. To work in space without wonder would be to miss the point of it all. The ISS is a symbol of international cooperation and scientific exploration. 15 nations contributed to its construction. Astronauts from around the world have lived and worked within its modules. The languages spoken there, the cultures represented, the perspectives brought together, all of this makes the station something more than a mere spacecraft. It is a human achievement in the fullest sense, a demonstration that our species can work together toward goals that transcend national boundaries. In an era often marked by conflict and division, the station floats on as a testament to cooperation. The Russian modules dock seamlessly with American modules. European and Japanese and Canadian systems integrate with the whole. The crew, regardless of their national origins, work together as a team, their differences less important than their shared mission, their shared home, their shared experience of wonder. The gentle physics of zero gravity is a source of inspiration for future generations. Children around the world watch videos from the station, see astronauts floating and playing and working, and dream of joining them someday. These dreams matter. They drive young people towards science and engineering, toward the skills and knowledge that will make the next generation of space exploration possible. The station is a promise kept to the future, a demonstration that humans can live beyond Earth, a stepping stone toward destinations more distant still. The Moon, Mars, the asteroids, eventually perhaps the moons of Jupiter and Saturn, all of these become imaginable because the station has proven that humans can live in space for extended periods. The gentle floating of astronauts today prepares the way for the journeys of tomorrow. Life aboard the ISS is a unique and unforgettable experience. Those who have lived there carry the memory for the rest of their lives, a reference point unlike any other, a perspective that shapes how they see everything that comes after. They have seen Earth from above. They have felt their bodies float. They have lived among the stars. Such experiences do not fade with time, but grow in significance, becoming more rather than less meaningful as the years pass. The ISS is a place where the gentle physics of zero gravity is lived every day. Not studied from afar, not imagined in theories, but lived in the most immediate and personal way. The physics becomes experience. The science becomes life. The equations become the feeling of floating, the sight of spherical water, the gentle push from wall to wall. This transformation of knowledge into experience is perhaps the deepest gift of human spaceflight. We can learn about microgravity from books and lectures. We can understand the orbital mechanics from equations and simulations. But only the astronauts know what it feels like, how it changes the texture of daily existence, what it means to be a floating being. Astronauts adapt to the challenges of microgravity with creativity and determination. The adaptation is never complete. There is always more to learn, always some new situation that requires a new solution. But the challenges are met, the problems are solved, the life goes on. Human ingenuity proves equal to the demands of this most demanding environment. This adaptability is itself inspiring. It suggests that whatever challenges the future holds, whether on Earth or beyond it, humans will find ways to meet them. We are a species defined by our ability to thrive in new environments, to solve problems we have never faced before, to make homes in places that should be uninhabitable. The station is proof of this capacity, a demonstration that the universe is not closed to us. The lack of gravity changes the way humans interact with their environment, but it also changes the way we think about ourselves, about our place in the cosmos, about what is possible. The astronauts who live in weightlessness for months at a time return with altered perspectives, with new understandings of what it means to be human in a universe far larger and stranger than daily life suggests. The gentle physics of zero gravity is a source of scientific discovery. We have spoken of the experiments, the research, the knowledge gained. But beyond the specific findings, beyond the data and the papers, and the technological applications, there is the larger discovery that humans can do this at all, that we can live in space, that we can conduct science there, that we can make our home among the stars, at least for a time. This discovery has implications far beyond any single experiment. It suggests a future in which humanity is not confined to one small planet, in which our species spreads outward to inhabit the solar system, and perhaps someday reach beyond it. The station is the first permanent step in that direction, the first demonstration that such a future is possible. Life aboard the ISS is a continuous journey of adaptation and exploration. The two go together. One cannot explore without adapting to what one finds, cannot adapt without being changed by the exploration. The astronauts who arrive at the station begin a process of transformation that continues throughout their stay and beyond. They explore not just space but themselves, not just microgravity but their own capacities. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. The two aspects are inseparable. The challenges, the difficulties of living without gravity's familiar support, these are the price of entry to the wonder. And the wonder, the beauty of floating, the perspective of altitude, the experience of living among the stars, this is the reward that makes the challenges worthwhile. The experience of floating is a peaceful and serene reminder of the beauty of space. Peace and serenity are not words often associated with spacecraft, with the dangerous enterprise of leaving Earth's protective envelope. But they are appropriate words for the inner experience of the astronauts, for the quiet moments when they float in the cupola watching Earth roll past, for the restful hours in their sleeping bags suspended in darkness. There is beauty in space, stark and terrible and magnificent. The blackness of the void, the brilliance of the stars, the curved horizon of Earth, the play of light at sunrise and sunset 16 times a day. The astronauts live immersed in this beauty, their days punctuated by moments of visual wonder that most humans will never see. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The two categories overlap more than we sometimes acknowledge. The greatest scientists have often been dreamers, their imaginations reaching beyond the known into the possible. And the dreamers who imagine futures in space are building on the science that makes those futures conceivable. The station bridges these two approaches to the cosmos. It is a place of rigorous science, where hypotheses are tested and data is gathered. It is also a place of dreams fulfilled, where humans actually live the experience of space that previous generations could only imagine. The science and the dreams support each other, each making the other more meaningful. Rest now, dear listener, in this place where science and poetry meet. The physics of floating is mathematical, expressible in equations. But the experience of floating is beyond mathematics, beyond language, a gift to the human spirit that words can only approach but never fully capture. You float now towards sleep, carried by processes as mathematical as orbital mechanics, as mysterious as the experience of dreaming. The physics runs in the background, the chemistry of your brain easing you toward rest. But the experience is yours alone, personal and immediate, as unique as the experience of any astronaut floating in the station's peaceful modules. Let the poetry of weightlessness carry you now. Let the wonder of possibility ease your mind. Let the gentle physics of everything lull you into the peaceful states beyond waking. Segment 9. The Rhythm of Days. Time passes differently in space, marked by rhythms both natural and artificial, both imposed and discovered. The astronauts aboard the station live in a world where the normal cues of day and night are replaced by the rapid cycling of orbital sunrise and sunset, where schedules are maintained by clocks rather than sunlight, where the rhythm of work and rest must be consciously constructed rather than naturally occurring. Life aboard the ISS is a testament to the resilience and ingenuity of humans. That people can maintain their sense of time, their sleep schedules, their productivity, in an environment so different from Earth is a remarkable achievement. It requires discipline, cooperation, and a willingness to follow schedules that have no natural basis in the environment around them. The gentle physics of zero gravity is a source of wonder and discovery. Every day aboard the station brings small moments of wonder, small discoveries about how things work in this environment. Even crew members who have been in space for months find new aspects of their situation to notice, new behaviors of objects to observe, new ways that weightlessness affects their activities. The ISS is a place where the gentle physics of zero gravity is lived every day. The repetition is part of the experience, the daily renewal of an extraordinary situation. Each morning, astronauts wake to another day of floating, another day of carefully managed routines, another day of scientific work and personal adaptation. Astronauts adapt to the challenges of microgravity with creativity and determination. The adaptation is ongoing, a process rather than an achievement. There is no point at which an astronaut can say that they have fully adapted, that they have nothing more to learn about living in space. The challenges continue to arise, and the creativity continues to meet them. The lack of gravity changes the way humans interact with their environment. This interaction is constant, a continuous dialogue between body and world. Every movement is a conversation with microgravity, every task a negotiation with the unique conditions of the orbital environment. The interaction shapes how astronauts think, how they plan, how they approach problems. The gentle physics of zero gravity is a source of scientific discovery. The discoveries are not limited to formal experiments. Every day aboard the station generates informal observations, casual insights, unexpected learnings that arise from the experience of living in a new environment. The astronauts themselves are instruments of discovery, their daily experiences generating knowledge as valuable as any experiment. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey has no predetermined endpoint, no final destination after which the traveling stops. Each day is another step in the journey, another moment in an ongoing process that will continue as long as humans live in space. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. The duality persists, the challenge and the wonder intertwined, each defining and enriching the other. The challenges make the wonder meaningful. The wonder makes the challenges worthwhile. The experience of floating is a peaceful and serene reminder of the beauty of space. The peace and serenity are available to the astronauts even in the midst of busy days, even during complex technical work. A glance out a window, a moment of floating motionless in a quiet module, a pause between tasks to notice the extraordinary nature of the ordinary. These moments of serenity punctuate the days and make them sustainable. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The inspiration flows in both directions, from Earth to space and from space to Earth. Scientists on the ground are inspired by what the astronauts achieve. The astronauts are inspired by the dreams of those who sent them there, by the hopes invested in their mission, by the generations of thinkers and builders who made their presence in space possible. Life aboard the ISS is a testament to the resilience and ingenuity of humans. The testament is renewed each day, each problem solved, each routine maintained, each task completed. The resilience and ingenuity are not abstract qualities, but lived realities, demonstrated in the concrete actions of people going about their days in an extraordinary environment. The gentle physics of zero gravity is a source of wonder and discovery. The wonder and discovery are not separate experiences, but aspects of the same experience. To wonder is to be open to discovery. To discover is to renew wonder. The astronauts live in this cycle, their days filled with wondering and discovering, their experiences constantly refreshed by the strangeness of their situation. The ISS is a place where the gentle physics of zero gravity is lived every day. The phrase bears repetition because it captures something essential about the station's purpose. It exists so that humans can live in microgravity, can experience what that living is like, can learn what it teaches. The living itself is the point, the foundation on which everything else rests. Astronauts adapt to the challenges of microgravity with creativity and determination. The adaptation is both individual and collective, each astronaut learning for themselves while also contributing to the shared knowledge of the space program. What one crew member discovers, all future crew members can benefit from. The learning accumulates, the adaptation deepens, the capability grows. The lack of gravity changes the way humans interact with their environment. The change is comprehensive, affecting not just physical actions, but mental approaches, not just how things are done, but how they are thought about. The environment teaches, the humans learn. Both are changed by the interaction. The gentle physics of zero gravity is a source of scientific discovery. The discoveries range from the specific to the general, from particular findings about particular phenomena to broader insights about how the universe works. Each discovery is a piece of a larger puzzle, a contribution to a growing understanding that will eventually reshape how we think about everything. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey is both personal and collective. Each astronaut travels their own path through their time in space. The space program as a whole travels a longer path. Decades of accumulated experience moving toward destinations not yet reached. Rest now, dear listener, as we continue this journey together. The rhythm of your rest follows its own patterns, your body's own cycles of depth and lightness, your mind's own movements toward and away from consciousness. These rhythms are as natural as the rhythms of the station's orbit, as reliable as the cycling of its artificial days. Let the rhythm carry you. Let the pattern unfold. Let the journey continue without effort, the destination approaching without haste. The astronauts float through their days. You float through this rest. Both are journeys. Both are arrivals. Both are moments in the larger pattern of living. Segment 10. The view from above. Of all the experiences that space travel offers, perhaps none is more universally cherished than the view of Earth from above. Astronauts who have dedicated their lives to engineering and science, who approach their missions with professional focus and technical precision, describe seeing their home planet from space in terms more appropriate to poets and mystics than to technologists. The view changes people. It reorders priorities. It creates new understanding. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. But floating to a window and looking down at Earth, the wonder overwhelms everything else. The challenges fade into background. The technical requirements of life support and navigation and exercise become mere details. What remains is the view, the profound and transforming view. The experience of floating is a peaceful and serene reminder of the beauty of space, And what is more beautiful, more peace-inducing than the sight of Earth from above? The planet hangs in the blackness, alone and luminous, wrapped in its thin atmosphere, rotating slowly in the eternal night of space. There is nothing else in the field of view that compares, nothing that can compete for attention with the home of all known life, the source of all human experience. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The view from above is the greatest single source of that inspiration. Astronauts return from space with a changed relationship to their planet, with an awareness of its fragility and beauty that cannot be achieved any other way. This awareness drives them to protect what they have seen, to share their perspective, to help others understand what the view has taught them. Life aboard the ISS is a testament to the resilience and ingenuity of humans. The view from above puts this human achievement in its cosmic context. Against the vastness of space, against the loneliness of the void, humans have built a home among the stars. The station is tiny in the scale of the cosmos, but it represents something immeasurably large in the scale of human accomplishment. The gentle physics of zero gravity is a source of wonder and discovery. The view from above is part of that discovery, perhaps the most important part. To see Earth from space is to discover it anew, to see it as it truly is, rather than as daily experience presents it. The discovery is both scientific and spiritual, both objective and deeply personal. The ISS is a place where the gentle physics of zero gravity is lived every day, and every day the astronauts can float to a window and see their world from a perspective that no human before the space age ever had. The daily availability of this view is extraordinary. Previous generations could only dream of such a sight. The astronauts live with it as part of their routine. Astronauts adapt to the challenges of microgravity with creativity and determination. They also adapt to the view, though adaptation may not be the right word. They become accustomed to the practical aspects of window gazing, the best times to observe different parts of the planet, the techniques for photography, the schedules that allow time for contemplation. But the emotional impact of the view never fully fades. The lack of gravity changes the way humans interact with their environment. Floating before a window, watching the world turn below, the interaction is pure observation, pure reception. The astronaut does nothing but look, and in that looking receives something that cannot be received any other way. The interaction is one-directional, the planet giving, the human receiving. The gentle physics of zero gravity is a source of scientific discovery. The view from above has scientific value, certainly. Earth observation is a significant part of the station's mission. The astronauts photographing and recording the planet's surface, its weather patterns, its changing features. But the scientific value is joined by something more, something that transcends data and instruments. Life aboard the ISS is a continuous journey of adaptation and exploration. The view from above is part of that exploration, the exploration of what it means to be human in a cosmos far larger than our daily experience suggests. The astronauts explore space in the physical sense, traveling to orbit. They also explore their own responses to that travel, their own transformations in the face of the view. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. The view from above is entirely wonder, without challenge, without difficulty. It asks nothing of the observer but openness. It gives everything it has, freely, to anyone who looks. The experience of floating is a peaceful and serene reminder of the beauty of space. Looking at Earth from above, the peace deepens, the serenity expands. The planet is so beautiful, so perfect in its position against the dark, so clearly the center of everything that matters to human beings. The observer floats in peace, the planet rotates in beauty, and for a moment, everything is exactly as it should be. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The view from above inspires beyond science, beyond dreams, into something like reverence. The astronauts do not use religious language often, but many report that seeing Earth from space was a spiritual experience, a moment of connection with something larger than themselves, a glimpse of the sacred. Life aboard the ISS is a testament to the resilience and ingenuity of humans. It is also a testament to human aspiration, to the desire to see beyond the horizon, to know what lies beyond the familiar. The view from above is the fulfillment of this aspiration, the achievement of a perspective that generations dreamed of but never attained. The gentle physics of zero gravity is a source of wonder and discovery. The view from above is the culmination of that wonder, the greatest discovery that space travel offers. Not a discovery of something out there in space, but a rediscovery of something we thought we knew, our own world, seen now as if for the first time. Let this view settle into your rest, dear listener. Imagine Earth as the astronauts see it, blue and white and brown and green, spinning slowly in endless night. Your home is there, and you are cradled on its surface, even as you imagine it from above. The view holds you, even as you hold the view in your imagination. The astronauts carry this view with them always, a permanent gift of their time in space. You can carry a version of it too, a reminder that the planet is one place, that all life shares this spinning sphere, that from above the divisions we create disappear, and only the unity remains. Rest now with this unity. Rest with the view. Rest with the knowledge that you are part of something beautiful, something seen best from far away, something that looks like home because it is, the only home we have, precious and lovely, floating in the gentle physics of space. Segment 11. The Silent Hours. Night falls differently in space, if night can be said to fall at all in a place where darkness and light alternate 16 times a day. But there are quiet hours on the station, times when the crew sleeps and the laboratories, still and only the constant hum of life support systems, breaks the silence. These are the gentle hours, the peaceful hours, when the station drifts through its orbit with its human cargo at rest. The ISS is a place where the gentle physics of zero gravity is lived every day. But in the silent hours, the living becomes especially quiet, especially peaceful. The astronauts float in their sleeping bags, their bodies relaxed, their minds wandering through dreams. The station carries them on through the night, through the orbital dark that is never entirely dark, through the cycling of day and night that continues whether or not anyone is awake to see it. Astronauts adapt to the challenges of microgravity with creativity and determination. Sleep itself is an adaptation, the finding of rest in a place where the normal cues for rest are absent. The astronauts have learned to sleep in weightlessness, to find comfort in floating, to achieve the deep rest that their bodies and minds require. This adaptation is one of the most important for long-duration missions. The lack of gravity changes the way humans interact with their environment. In sleep, the interaction becomes minimal, the human body at its most passive, the environment at its most supportive. The sleeping bag holds the astronaut gently in place. The air circulation maintains the proper atmosphere. The station continues its endless orbit. The interaction is reduced to the essentials, the basic requirements for life and rest. The gentle physics of zero gravity is a source of scientific discovery. Even sleep is studied. The patterns of rest in space compared to patterns on Earth, the effects of microgravity on the quality and nature of sleep. The silent hours generate data even as the crew rests, the monitoring equipment recording what the sleeping astronauts cannot observe. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey continues through the night, even when the travelers are unaware. The station moves on through its orbit. The Earth rotates beneath. The sun rises and sets and rises again. The journey has no pause, no stopping point, no true night in the sense of ending and rest before a new beginning. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. In the silent hours, the wonder predominates. There are no challenges to meet when one is asleep, no problems to solve, no adaptations to make. There is only floating, only breathing, only the gentle rest that gravity does not interrupt. The experience of floating is a peaceful and serene reminder of the beauty of space. This peace reaches its fullness in sleep, when the experience becomes entirely restful, when the floating becomes a kind of cradle, when the body surrenders completely to the environment. The peace is not earned, but given, not achieved, but received. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The dreams that come in space may be different from earthly dreams, shaped by the experience of floating, influenced by the strange environment. Some astronauts report that their dreams incorporate the sensation of weightlessness, that they dream of flying more often than they did on Earth, that the boundaries between sleeping and floating become blurred. Life aboard the ISS is a testament to the resilience and ingenuity of humans. Sleep itself is a testament to resilience, the body's ability to find rest wherever it is, to take the restoration it needs from whatever environment it finds itself in. The human body knows how to sleep in space, adapts to the conditions, finds the rest it requires. The gentle physics of zero gravity is a source of wonder and discovery. The wonder persists in sleep, if only unconsciously. The astronauts who wake from sleep in space report that those first moments of consciousness, when they realize again where they are, carry a particular quality of wonder. The daily rediscovery of their situation refreshes the extraordinary nature of their experience. The ISS is a place where the gentle physics of zero gravity is lived every day. The silent hours are part of that living, the nighttime portion of the daily cycle. To live somewhere includes sleeping there, resting there, finding peace there. The station is a home because humans sleep there, not just work there. Astronauts adapt to the challenges of microgravity with creativity and determination. They also adapt to the rhythms of rest, finding when and how they sleep best, creating the routines that lead to satisfying sleep. These personal adaptations are important for health and happiness, for the ability to function well during waking hours. The lack of gravity changes the way humans interact with their environment. In the silent hours, this changed interaction becomes entirely supportive. The environment holds the human, cares for the human, maintains the conditions for human life while the human rests. It is a relationship of pure support, the station giving and the human receiving. The gentle physics of zero gravity is a source of scientific discovery, but in the silent hours, discovery pauses. The accumulation of knowledge takes a break while the knowers rest. This pause is necessary, part of the rhythm that makes sustained work possible. Discovery requires rest as much as it requires effort. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey includes these pauses, these silent hours, when exploration seems to stop but actually continues in the simple act of being there, of existing in a place where no humans existed before, of sleeping among the stars. Rest with the silent station now, dear listener. The astronauts sleep in their floating bags. You rest where you are, equally at peace. The physics is different, the environment is different, but the need for rest is the same. The human body requires these pauses, these times of quiet restoration. The station drifts on through the orbital night. You drift through your own night, your own peaceful passage toward morning. Both journeys are gentle, both are silent, both carry sleepers toward whatever comes next. Let the silence hold you. Let the peace deepen. Let the gentle hours carry you where you need to go. Segment 12. The community of explorers. Human beings are social creatures, shaped by millions of years of living in groups, cooperating and competing and caring for one another. This social nature does not disappear when humans venture into space. If anything, it becomes more important, more central to survival and happiness. The astronauts aboard the station are not merely technicians performing tasks in isolation, but members of a community, colleagues and friends, living and working together in extraordinary circumstances. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. But it is also a place where human relationships unfold, where personalities interact, where the complex dynamics of group living play out in a confined and unusual space. The physics shapes the relationships shape the experience of the physics. The experience of floating is a peaceful and serene reminder of the beauty of space. It is also a shared experience, something that all the astronauts have in common, something they can discuss and joke about and wonder at together. The sharing deepens the experience, makes it more meaningful, adds layers of understanding that solitary experience could not provide. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The inspiration is amplified when shared, when one astronaut's observation sparks another's insight, when collective wonder builds on individual moments of appreciation. The community of explorers is also a community of inspiration. Life aboard the ISS is a testament to the resilience and ingenuity of humans. This testament is collective as well as individual. The resilience is the resilience of a team working together. The ingenuity is the ingenuity of many minds combining their creativity. No single astronaut could maintain the station alone. The collective is essential. The gentle physics of zero gravity is a source of wonder and discovery. Discovery proceeds best in community, in the exchange of ideas, in the questioning and building that happens when minds work together. The astronauts share their discoveries with each other, and this sharing advances understanding faster than isolated work ever could. The ISS is a place where the gentle physics of zero gravity is lived every day. It is lived together in community as a shared experience that binds the crew into something more than a collection of individuals. The shared living creates shared meaning, shared memories, shared identity. Astronauts adapt to the challenges of microgravity with creativity and determination. They also adapt to each other, learning to work together, learning to live in close quarters, learning the patience and tolerance and appreciation that long-duration cohabitation requires. These social adaptations are as important as the physical ones. The lack of gravity changes the way humans interact with their environment. It also changes the way they interact with each other. The physical dynamics of conversation and collaboration transformed by weightlessness. Astronauts can face each other from any angle, can float in configurations impossible on Earth, can relate to one another in physical space in entirely new ways. The gentle physics of zero gravity is a source of scientific discovery. Much of this discovery depends on teamwork, on the division of labor, on the coordination of complex activities. Science is a collective enterprise, and science in space is especially so, requiring the contributions of many people working toward shared goals. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey is made together in company with others who share the experience. This companionship is essential for psychological health, for the ability to maintain morale and motivation over months of isolation from the broader human community. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. The community of astronauts faces the challenges together, shares the wonder together. Neither would be the same alone. The experience of space is fundamentally a shared experience. The experience of floating is a peaceful and serene reminder of the beauty of space. This peace is deepened by community, by the knowledge that others share it, by the conversations that explore and expand it. Peace in isolation is thin, peace in community is rich. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The community of astronauts is connected to a larger community on Earth, the thousands of people who support the mission, the millions who follow it with interest and hope. This broader community shares in the inspiration, participates in the endeavor. Life aboard the ISS is a testament to the resilience and ingenuity of humans. The testament extends beyond the astronauts to all who make their mission possible. The engineers and scientists, the flight controllers and medical staff, the trainers and administrators, all are part of the community that maintains human presence in space. The gentle physics of zero gravity is a source of wonder and discovery. Wonder and discovery are meant to be shared. The astronauts share with each other. They share with the world through photographs and videos and messages. They share with the future through the knowledge they accumulate and the paths they open. Rest now with the image of this community, dear listener. The astronauts working together, supporting each other, sharing their extraordinary experience. Human beings, even in the isolation of space, remain social creatures, finding meaning in connection, drawing strength from community. You too are part of a community, however distant it may seem in this quiet moment. The people who care for you, the people you care for, the broader human family to which we all belong. Rest in this belonging. Rest in this connection. Rest in the knowledge that you are not alone. Segment 13. The Passage of Seasons. Time moves in many cycles, from the rapid 90-minute orbits of the station to the slow turning of years that marks career and life. The astronauts who live aboard the station experience time differently than those on Earth, but they remain connected to the larger rhythms that govern human existence. They know when seasons change on the surface below, even if they cannot feel the temperature shift. They mark birthdays and holidays, even if the celebrations take unfamiliar forms. The ISS is a place where the gentle physics of zero gravity is lived every day. The days accumulate into weeks, the weeks into months, and eventually the mission ends and the astronaut returns to Earth. The passage of time in space is a transformation, a journey not just through orbit, but through personal change. Astronauts adapt to the challenges of microgravity with creativity and determination. Over time, the adaptations deepen. What was difficult in the first days becomes natural after weeks. What was strange becomes familiar. The astronaut who begins a mission as a newcomer to space ends it as a veteran, changed by the experience in ways that only become fully apparent upon return. The lack of gravity changes the way humans interact with their environment. These changes accumulate over time, the effects of microgravity on body and mind becoming more pronounced as the days pass. The bones and muscles continue their slow adaptation. The brain continues its adjustment to the new normal. The person becomes, in some ways, a different person than they were at launch. The gentle physics of zero gravity is a source of scientific discovery. The discoveries that matter most often come from long-duration research, from the patient accumulation of data over weeks and months. Time is essential for this work. Quick visits cannot achieve what extended stays make possible. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey has its seasons, its phases, its passages. There is the excitement of arrival, the adjustment of the early days, the settling into routine of the middle period, the anticipation of return as the mission draws to its close. Each phase has its character, its challenges, its particular form of wonder. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. As time passes, the balance between challenge and wonder shifts. The challenges become more manageable as adaptation proceeds. The wonder remains, returning in unexpected moments, never entirely normalized away. The experience of floating is a peaceful and serene reminder of the beauty of space. With time, this peace deepens. The astronaut becomes accustomed to floating, no longer needs to think about it, can surrender to it completely. The serenity becomes a foundation, a baseline state from which all activity proceeds. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The inspiration that comes from extended experience differs from the inspiration of first encounter. It is deeper, more textured, informed by the accumulated observations of many days. The long-duration astronaut has more to share than the brief visitor. Life aboard the ISS is a testament to the resilience and ingenuity of humans. The testament grows stronger as missions lengthen, as humans demonstrate their ability to thrive in space for months at a time, as the limits of adaptation are explored and extended. The gentle physics of zero gravity is a source of wonder and discovery. Time allows this wonder and discovery to mature, to develop complexity, to integrate into a comprehensive understanding that brief experience cannot provide. The ISS is a place where the gentle physics of zero gravity is lived every day. Living is not a moment but a process, not an event but a duration. The living that happens on the station unfolds over time, each day building on the ones before, each week deepening the experience of all the previous weeks. Astronauts adapt to the challenges of microgravity with creativity and determination. The creativity and determination are sustained over time, refreshed by the ongoing novelty of the experience, maintained by the commitment that brought the astronaut to space in the first place. The lack of gravity changes the way humans interact with their environment. These changes take time to fully manifest, time to fully understand. The astronaut who returns from a long mission has stories to tell that the brief visitor never encountered, insights to share that only extended experience can provide. The gentle physics of zero gravity is a source of scientific discovery. The discoveries accumulate like the days, each one a small addition to the growing body of knowledge, together building toward understanding that no single discovery could achieve. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey is measured in days but felt in experiences, counted in orbits but remembered in moments. Time passes, the journey continues. The seasons of space unfold in their own rhythm. Rest now with the sense of time's passage, dear listener. Your rest tonight is a moment in the longer journey of your life, a single orbit in the larger cycles of your existence. The seasons turn on Earth, the missions cycle through the station. Your nights and days follow each other in endless succession. Let time flow gently. Let the moment expand into peace. The passage of seasons continues, but this moment is yours, a pause in the ongoing journey, a rest in the midst of the longer motion. Segment 14. The Promise of Return. Every mission to space includes within it the promise of return. The astronauts who leave Earth plan to come back, work toward coming back, eventually make the journey back to the world that remains their true and permanent home. This promise of return shapes the experience of being away, gives it meaning and context, allows the extraordinary experience of space to be understood as a chapter in a longer story. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder, but it is not meant to be a permanent home for any individual. The astronauts are visitors, even the longest-serving ones, even those who have spent a year or more in orbit. The station is a waypoint, not a destination. The experience of floating is a peaceful and serene reminder of the beauty of space. And yet the astronauts know they will not float forever, that gravity awaits them, that the return to weight is part of their journey. This knowledge does not diminish the floating. If anything, it heightens appreciation for what cannot last forever. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The return to Earth is also inspiring. The triumphant completion of the mission, the reunion with loved ones, the bringing back of experience and knowledge to share with the world. The return is part of the story, essential to its meaning. Life aboard the ISS is a testament to the resilience and ingenuity of humans. So is the return, the readaptation to Earth gravity, the recovery of strength and function that were diminished by months in space. The astronaut who returns demonstrates resilience in returning to normal, not just in surviving the time away. The gentle physics of zero gravity is a source of wonder and discovery. The discoveries made in space are meant to be shared on Earth, to benefit those who never leave the surface, to advance knowledge for all of humanity. The return makes this sharing possible. The ISS is a place where the gentle physics of zero gravity is lived every day. But the living has an end point, a known duration, a return trip already scheduled before departure. This structure gives shape to the experience, makes it possible to fully engage with the present because the future is secure. Astronauts adapt to the challenges of microgravity with creativity and determination. They also prepare for the challenges of return, knowing that the transition back to Earth gravity will require its own adaptations. The body that has adjusted to floating will need to readjust to weight. The mind that has normalized microgravity will need to re-normalize Earth's pull. The lack of gravity changes the way humans interact with their environment. But the change is temporary for the astronauts, a phase in their lives rather than a permanent condition. They will return to an environment where gravity is constant, where weight is normal, where the rules they grew up with apply once again. The gentle physics of zero gravity is a source of scientific discovery, but the scientists who conduct experiments in space return to laboratories on Earth to analyze their results, to place their findings in context, to plan the next investigations. The discovery that happens in space is completed on Earth. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey includes return as its final phase, the closing of the circle, the completion of the arc that began with launch. Every journey has an ending, this journey ends at home. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. The return is not escape from challenge, but transition to different challenges. Not loss of wonder, but exchange for different wonders. The wonders of Earth await the returning astronaut. Familiar wonders made new by the perspective space has provided. The experience of floating is a peaceful and serene reminder of the beauty of space. The experience of return is an equally powerful reminder of the beauty of Earth, of home, of the world that evolved us and sustains us and will always be our first and most essential habitat. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The return inspires as well. The sight of the returning capsule, the welcoming of the astronauts back to Earth, the celebration of what they have done and learned and become. Rest now with the promise of return, dear listener. Whatever journey you are on, whatever distance you have traveled from your normal state, you will return. This rest is itself a journey, a departure from wakefulness that will end in waking. The promise of return makes the journey meaningful. You will wake in the morning, returned from the journey of sleep. The astronauts will return to Earth, completed their missions, ready for whatever comes next. All journeys end in return, all departures lead eventually to arrival. Let the promise hold you. Let the return wait patiently. For now, rest in the journey itself, in the floating passage through the night, in the gentle physics of letting go. Segment 15. The continuing story. The story of human spaceflight is not finished. It continues to unfold, chapter by chapter, mission by mission, discovery by discovery. The astronauts who have lived aboard the station are characters in this ongoing narrative, their experiences shaping the possibilities for those who will follow. The future stretches out before us, filled with destinations not yet reached, discoveries not yet made, adventures not yet imagined. The ISS is a place where the gentle physics of zero gravity is lived every day. It is also a place where the future is being built, where the knowledge and experience needed for longer missions are being accumulated, where the human species is learning what it needs to learn to become a spacefaring civilization. Astronauts adapt to the challenges of microgravity with creativity and determination. This adaptation creates templates for future adaptation, methods and techniques that will be used by astronauts on missions to the Moon and Mars and beyond. What is learned on the station will enable what is accomplished elsewhere. The lack of gravity changes the way humans interact with their environment. Understanding these changes, developing countermeasures for their negative effects, learning to take advantage of their positive possibilities. This work prepares the way for extended human presence in space. The gentle physics of zero gravity is a source of scientific discovery. The discoveries made on the station are stepping stones toward discoveries that will be made in other places by other explorers in times yet to come. Science builds on itself. The station's science will support science for generations. Life aboard the ISS is a continuous journey of adaptation and exploration. This journey is part of a larger journey, the journey of humanity into space, the gradual expansion of human presence beyond the planet of our origin. The station is a chapter in a very long book. The ISS is a place where the gentle physics of zero gravity is both a challenge and a wonder. Future missions will face their own challenges, their own wonders. The lessons learned in meeting today's challenges will inform the strategies for meeting tomorrow's. The wonder experienced today will be echoed by wonders yet to come. The experience of floating is a peaceful and serene reminder of the beauty of space. Future astronauts will have their own experiences of floating in different vehicles, in different places, perhaps around other worlds. The serenity of microgravity will accompany them wherever they go. The gentle physics of zero gravity is a source of inspiration for scientists and dreamers alike. The inspiration flows forward in time as well as outward through space. The children who watch astronauts float today will build the spacecraft of tomorrow. The dreams inspired by the station will become the realities of the next century. Life aboard the ISS is a testament to the resilience and ingenuity of humans. This testament stands as encouragement for future efforts, proof that challenges can be met, that environments can be adapted to, that humans can thrive far from home. The testament says, "If we could do this, we can do more." The gentle physics of zero gravity is a source of wonder and discovery. The wonder and discovery will continue, will expand, will reach new places and reveal new truths. The story is not ending, but continuing, not finishing, but unfolding. The ISS is a place where the gentle physics of zero gravity is lived every day. Someday, perhaps, humans will live in microgravity permanently, in habitats around the Moon or Mars, in stations orbiting other planets, in vessels traveling between stars. The daily living of microgravity that happens now is practice for that future. Astronauts adapt to the challenges of microgravity with creativity and determination. Future generations will inherit this creativity and determination, will apply it to challenges we cannot yet imagine, will take humanity to places we cannot yet conceive. The lack of gravity changes the way humans interact with their environment. These changes are being studied and understood, preparing the way for environments where different rules apply, for futures where human life expands beyond its current boundaries. The gentle physics of zero gravity is a source of scientific discovery. The discoveries continue, will continue, must continue if humanity is to reach the potential that space offers. The station is a beginning, not an end. Life aboard the ISS is a continuous journey of adaptation and exploration. The journey continues beyond any individual mission, beyond any generation of explorers, into a future as vast as space itself. Rest now, dear listener, with the sense of this continuing story. Your rest tonight is a small chapter in your own story, a moment in a narrative that extends from your past into your future. The story continues when you wake. The story continues for humanity among the stars. The astronauts float through their station. The station floats through its orbit. The Earth floats through its path around the Sun. The Sun floats through its journey around the galaxy. Everything floats, everything moves, everything continues in the endless unfolding of the cosmic story. You are part of this story, part of this floating, part of this continuing. Rest now in your place within the great narrative. Rest in the knowledge that the story goes on, that the journey continues, that the gentle physics of everything carries us all toward whatever comes next. The wonder continues, the discovery continues, the floating continues. Rest now, sleep well, and dream of stars. Closing meditation, a final journey into rest. As we come to the end of our exploration together, let us take one final journey through the gentle physics of zero gravity, one last meditation on the wonders we have contemplated. The night surrounds you now, dear listener, as completely as space surrounds the station. The darkness is soft and welcoming, a blanket of quiet that muffles the noise of the day and leaves only peace. Imagine yourself floating one last time. Your body has released all tension, all weight, all connection to the surface beneath you. You hover in a space between waking and dreaming, suspended in the liminal zone where consciousness softens and dissolves. There is no effort required to stay here. The gentle physics of rest holds you as surely as orbital mechanics hold the station. The astronauts aboard the International Space Station have shown us something profound about human capability. They have demonstrated that we can adapt to environments utterly different from those in which we evolved. They have proven that the human spirit can find peace and wonder in the most unlikely of places. They have established that even in the void of space, surrounded by darkness and danger, human beings can make a home. This adaptability lives within you too. Whatever circumstances you find yourself in, whatever challenges you face, whatever strange territories life takes you through, you carry within you the same capacity for adjustment and resilience that the astronauts demonstrate daily. You can find peace in unfamiliar places. You can make a home wherever you are. You can float through difficulty with grace. The station continues its orbit as you rest. Right now, at this very moment, human beings are floating through the modules, conducting experiments, gazing out windows at the curving Earth below. They are living proof of human aspiration, human achievement, human presence beyond the bounds of our home world. Their light continues while you sleep, a constant beacon in the night sky, a reminder that exploration never ceases. The facts we have explored tonight will remain with you in some form, settling into the substrate of your knowledge, enriching your understanding of what life in space is like. Perhaps in dreams tonight, you will float through corridors of your imagination, will see Earth from above, will experience the gentle wonder of weightlessness. These dreams would be gifts from the journey we have shared, echoes of the exploration continuing in the depths of sleep. The physics of the universe is gentle in its fundamental nature. Gravity pulls, but does not push aggressively. Light travels, but does not intrude. Time flows, but does not rush. The forces that govern reality operate with a kind of quiet patience, working their effects over moments and millennia with equal serenity. The gentle physics that allows astronauts to float is the same physics that holds you to your bed, that keeps the air in your lungs, that maintains the conditions for your existence. It is all one system, one set of principles, one continuous fabric of cause and effect. You are part of this fabric, woven into the physics as surely as the station is. Every atom in your body was forged in stars. Every breath you take exchanges molecules with the atmosphere that all life shares. Every heartbeat follows patterns established in the earliest days of evolution. You belong to the universe, and the universe holds you gently as microgravity holds a floating astronaut. Let this belonging comfort you as you drift deeper into rest. You are not alone in the cosmos, but connected to everything. You are not a stranger to the universe, but a native of it, born from its processes, sustained by its physics, returning eventually to its cycles. The same wonder that astronauts feel when looking down at Earth, you can feel when looking up at the stars, when contemplating your place in the great dance of existence. The night deepens around you. The quiet grows more complete. The floating sensation of deep relaxation spreads through every part of your being. There is nothing to do now but rest, nothing to think about but the gentle darkness, nothing to feel but the peaceful release of consciousness into sleep. The astronauts sleep in their orbital home, and you sleep in yours. Both are valid, both are real, both are expressions of the human need for rest and renewal. The physics is different, but the peace is the same. The environment is different, but the surrender is equivalent. You and they share in the universal experience of letting go, of allowing sleep to take hold, of trusting the night to carry you through to morning. Tomorrow will bring its own concerns, its own activities, its own demands on your attention and energy. But tomorrow is not yet here. Tonight there is only rest, only floating, only the gentle passage through the hours of darkness. The station will continue its orbit while you sleep. The world will continue its rotation. Life will continue in all its forms, on the surface and in orbit, in waking and in sleeping. You are held by forces you do not need to understand, carried by processes you do not need to control, supported by a universe that operates according to principles as reliable as they are mysterious. The same physics that keeps planets in their orbits keeps you breathing in your sleep. The same forces that shape galaxies shape the dreams that move through your resting mind. Trust these forces now. Let them carry you. Surrender to the gentle physics of rest as the astronauts surrender to the gentle physics of orbit. Both are forms of falling, both are forms of floating, both are forms of letting gravity or its absence do its work. The night holds you. The quiet surrounds you. The peace permeates you. Float now into deepest rest. Let the darkness be complete. Let the silence be total. Let the floating be without end. The gentle physics of zero gravity has been our guide tonight, showing us wonders beyond the Earth, revealing truths about human capability and cosmic law. Carry these wonders into your dreams. Let them color your sleep with images of floating astronauts and spherical water and flames that burn in balls. The station sails on through the void, a small vessel of life in the enormous emptiness. You sail on through the night, a small vessel of consciousness in the vast ocean of sleep. Both journeys are sacred. Both journeys are mysterious. Both journeys are part of the larger journey that is existence itself. Rest well, dear listener. Rest deeply and completely. The gentle physics of everything holds you safe. The darkness is a friend. The floating is a gift. Dream now of stars. Dream of floating. Dream of peace. And when morning comes, you will wake refreshed, carrying with you some trace of the wonder we have shared, some memory of the floating, some connection to the gentle physics that governs all things. Until then, rest, just rest, float and rest. in the gentle physics of the night. The gentle physics of zero gravity. Life aboard the ISS narration, a sleep and relaxation experience. Thank you for listening.